Hello students, myself S.K.Jadhav from Department of Electronic Science, KTHM College, Nasik. In previous lecture, we have discussed about the basic logic gates, applications of logic gates. The basic logic gates, that is OR gate, AND gate and NOT gate using diodes and transistors. In this lecture, you will learn about the derived logic gates such as NAND, NOR, XOR and XNOR gates. In addition, you will understand the concept of universal logic gates. You will also study how NAND and NOR gates can be used in constructing other basic logic gates such as OR and 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 NOT gate. Let us now study NAND gate, that is not AND gate. It can be obtained by connecting a NOT gate at the output of an AND gate. The logic symbol for NAND gate is shown in figure A. It is basically performs logical ANDing and then provides inverted or complemented output. In the NAND gate, which is constructed using switch analogy, the switches are in parallel with the battery and lamp. The NAND gate produces a high output when any of the inputs, either A or B or both, are low. That means the lamp is on with the condition either A or B or both switches are low. That means the lamp is on with the condition either A or B or both switches are open, or A equal to 0 or B equal to 0 or A and B equal to 0. NAND gate produces low output when both the inputs are at high level. That means the lamp is off when both the switches are closed. The operation of NAND gate is shown in truth table. This truth table shows when A equal to 0, B equal to 0, then the output equal to 1. When A equal to 0, B equal to 1, then output is equal to 1. And when A equal to 1, B is equal to 0, then output is equal to 1. And when both inputs, that is A and B, equal to 1, then output is equal to 0. That means the NAND gate produces a logic 1 if either one or both the inputs are at logic 0, else the output is at logic 0. Now let us discuss the NOR gate. NOR gate is a combination of OR and NOT gates. It provides OR function with inverted output. In the NOR gate circuit constructed using switch analogy, the individual switch is in parallel with the battery and lamp. NOR gate produces a low output when any of the inputs, either A or B or both, are at logic 1. That is, the lamp is off, either A or B or both switches are closed. The output of a NOR gate is at logic 1, that is at high state when both the inputs are at logic 0. That is, the lamp is on when both the switches are open. Therefore, we can say that the NOR gate produces a logic 0 if either or one or both the inputs are at logic 1, else the output is at logic 1. XOR gate or exclusive OR gate. Let us now study the truth table of XOR gate, that is exclusive OR gate. This gate is basically designed to exclude the condition of standard OR gate to generate real binary addition. The logic symbol of XOR gate or exclusive OR gate is shown in figure. The logical equation or Boolean expression of XOR gate is y is equal to A exclusive B or y is equal to AB bar plus A bar B. In the switch analogy, XOR gate is constructed using battery, lamp, and cross-connected switches. The output of XOR gate is high when any one of the input is high, that is, the lamp is on when any of the switch is closed. This in turn indicates that XOR gate produces a logic high only when the two inputs are dissimilar or at opposite levels. The output of XOR gate is low when both the inputs are high or when both the inputs are low. That is, the lamp is off when both the switches are closed or when both the switches are open. That means the XOR gate produces a logic 1 only when the two inputs are at opposite levels, and it is shown in truth table. XNOR gate or exclusive NOR gate. Let us now study the truth table of XNOR gate, that is exclusive NOR gate. Exclusive NOR gate is obtained by combination of NOT and XOR gates. This gate is basically designed to compare the two inputs. In the switch analogy, XNOR gate can be constructed using a battery, bulb, and cross-connected switches. The output of XNOR gate is high, that is at logic 1, when both the inputs are either low or high, that is when the inputs are similar. That is, the lamp is on when both the switches are either open or closed. The output of XNOR gate is low when one of the input is high, that is when the inputs are dissimilar. That is, the lamp is off when one of the switches is closed. This in turn indicates that XNOR gate produces a high output only when two inputs are at the same logic level. We know that The logic equation for two input XOR gate is given by y is equal to AB bar plus A bar B or A exclusive B. Therefore, the output of XNOR gate can be obtained by complementing the output of XOR gate for corresponding input conditions. Universal logic gates. The logic gates that are capable of implementing any Boolean function without requiring any other type of gate is called universal logic gates. They are called as universal gates because they can realize all the binary operations. NAND and NOR gate are called as universal logic gates because all the basic logic gates, that is AND gate, OR gate and NOT gate, can be derived from NAND and NOR. NAND gate as an universal logic gate. Let us now study how NAND gate can be used as an universal logic gate. Let us now discuss the NOT gate using only NAND gate. A NAND gate can be used to construct NOT gate by connecting all its input together and applying input to a common input terminal, that is E. The output of NAND gate generates the output as NOT gate. It gives the truth table that is equivalent to NOT gate. That means when A equal to 0, then the output Y is equal to 1, and when A equal to 1, then it produces the output Y equal to 0. Then AND gate using NAND gate. Let us now consider the construction of AND gate using only NAND gate. For constructing AND gate, two NAND gates are required. The first NAND gate provides complement of A and B. That means here the output of first NAND gate will be A into B bar, that means complement of A into B. Then that output is given to the input of second NAND gate. The second NAND gate acts like an inverter. The double complement will cancel each other to provide AND gate. That is, the output of second NAND gate is A and B or A into B, and therefore it gives the output, that is A B is equal to A into B, and it gives the truth table that is equivalent to AND gate. That means when A equal to 0 and B equal to 0, then it gives the output 0. When A 0, then B 1 and it produces the output 0. When A is equal to 1, B is equal to 0, then it produces the output 0. And when A equal to 1, B equal to 1, then it produces the output 1. And therefore, this truth table is equivalent to truth table of AND gate. Let us now discuss the OR gate using only NAND gate. Consider the construction of OR gate using only NAND gate. 3 NAND gates are required to construct the OR gate. The first level 2 NAND gate will act like an inverter. These two inverters will complement the inputs. That means the first NAND gate will give the complement of input A, that will be the A bar, and second NAND gate will give the complement of input B, that is B bar. Then A bar and B bar, these two are given to the third AND gate, inputs of third AND gate, and the third NAND gate will perform ANDing of the complemented inputs first and then inverse the result. This provides final output as logical OR function. Then this table shows the truth table of OR gate. When A equal to 0, B is equal to 0, then it gives the output 0. When A equal to 0, B equal to 1, then it gives the output 1. When A equal to 1 and B equal to 0, then output Y is equal to 1. And when A equal to 1 and B equal to 1, it produces the output 1. That means it gives the truth table that is equivalent to OR gate. Let us now discuss the NOR gate as an universal logic gate. NOR gate using only NOR. Figure shows the implementation of basic logic gates using only NOR gates. A NOR gate can be used as a NOT gate by connecting all its input together and applying input to the common terminal. The output of NOR gate produces output as not A, that is negation or complement of A, and it gives the truth table that is equivalent to NOT gate. That means when A equal to 0, then it produces the output 1, and when A equal to 1, it produces the output 0. Then OR gate using only NOR gate. The construction of OR gate requires only two NOR gates. The first NOR gate provides complement of A or B, whereas the second NOR gate acts like an inverter. The double complement will cancel each other to provide action of OR gate. This table shows the truth table of OR gate using only NOR gate. That means when A and B both are equal to 0, 0, then it gives the output 0. When A equal to 0, B equal to 1, then it gives the output 1. When A equal to 1, B equal to 0, then it gives the output 1. And when both are equal to 1, 1, then it produces the output 1. That means this truth table is equivalent to the truth table of OR gate. AND gate using only NOR gate. Let us now consider the construction of AND gate using NOR gate. 3 NOR gates are required to construct the AND gate. In the first level, 2 NOR gates will act like an inverter. These two inverters will complement the input, that is A to A bar and B to B bar. Then the outputs of these two NOR gates is then given to the input of third NOR gate. The third NOR gate will perform ORing of the complemented inputs first and then inverse the result. This provides final output as logical AND function. Then this table shows the truth table of AND gate. When A equal to 0, B equal to 0, then output equal to 0. A equal to 0, B equal to 1, then it gives the output 0. When A equal to 1, B equal to 0, then it gives the output 0. And when A equal to 1, B equal to 1, then it produces the output 1. That means it gives the truth table that is equivalent to AND gate. Let us now summarize the topics that we have studied so far. NAND, NOR, XOR and XNOR gates are called as derived logic gates because these gates can be derived by using three basic logic gates, that is OR, AND and NOT gate. NAND and NOR gates are called as universal logic gates because we can build any basic logic gates, that is OR, AND NOT, by using NAND and NOR.